And today we're going to talk some more about solving systems by elimination, but today we're going to have a little bit of more steps. So we're going to talk about what having infinitely many solutions and having no solutions will look like when we use elimination. So first and foremost, to start off with, if both the variables cancel out and what is left is a true statement, then there's infinitely many solutions. So just like before, if your variables cancel and you end up with something that's -6 is equal to -6 or 2 is equal to 2, then there's infinitely many solutions. Then if there's no solution, that means the variables are going to cancel out, and it's a false statement. -2 is equal to 4, 6 is equal to 2.5. Okay, if it's not a true statement, it will never be a true statement, then that means that there is no solution. So let's take a look at some of those examples. So let's start by taking a look at number 1. So this one's set up for us to use elimination. Okay, it's in standard form. So what I notice is that here I have the same coefficient with opposite signs. The y's both have 3's, but the signs are opposite. That means it's ready for elimination because it's going to cancel out. Well, 6 plus -6 is going to give me 0x. 3y minus 3y is going to give me 0y. 12 minus 24 is -12. 0x plus 0y is the same as 0, so everything canceled out, and I'm left with 0 is equal to -12. Is 0 ever going to equal -12? No, so there's no solution. Okay. Alright, so let's take a look at number 2. So again, on number 2, I noticed for my x's that I have a -2x and a +2x. Same coefficient, opposite signs. So I can go ahead and I can add down the columns. -2x plus 2x is 0x. 6y minus 6y is 0y. And 14 minus 14 is going to be 0. So then I end up with 0 is equal to 0. Now that is true, and that will always be true. So that means that I have IMS, or infinitely many solutions. Okay? Alright, let's take a look at the steps. So all the steps are pretty much going to be the same for solving things by elimination. But there's 2 new steps that I want to make sure you note. So the first one is putting the equations in standard form. So remember, that means that you have your x's and y's on the same side and your thing that's just a number on the other side. The next thing you need to do is make sure that you multiply one or even both of the equations by a number. So the variable has opposite coefficients. So that's same coefficient, opposite signs. So you might have to multiply to make that be a true case. And then after that, everything is the same that we have been doing with systems, okay, using elimination. So let's take a look at what they would look like. Okay, so the first thing I notice about number 3 is that my x's have the same coefficient. I am halfway to what I need. Remember, I need same coefficient, opposite signs. So what I don't have is an opposite sign. So that's when I ask myself, okay, what do I need to have an opposite sign? What do I need? Well, I need one of them to be negative. So what I'm going to do to make it negative is I'm going to take this second equation and I'm going to multiply it by a -1. So I'm going to take and I'm going to change everything in that problem to be negative. Know that that doesn't change the equation. The value is still the same. It just makes it look a little different. So my top equation then is going to stay the exact same. My second equation, all of my signs are going to change. So when all of them changed, they all became negative. So now I notice that my x's have same coefficient, opposite signs. So now I can go ahead and add down the columns. Well, x minus x, that's 0x. 2y minus y is y. 10 minus 6 is 4. So then here I end up with y is equal to 4. So now I know that that is what y is equal to. So I can pick either one of these equations to plug y back into. Again, I usually just pick the first one. So I'm going to write that first equation out. And I'm going to keep everything the same, but wherever I see a y, I'm going to put a 4 in instead. So then I have x plus 2 times 4 is 8 is equal to 10. So then I'm going to subtract 8 from both sides. And then I get that x is equal to 2. So I want to write that out as a coordinate point, x, y. So my solution then is 2, 4. Taking a look at number 4. So for number 4, I notice that on my y's, I have the same coefficient, but I don't have the opposite signs. So I want to do exactly like I did on number 3. I'm going to take the second equation. You could take the first if you wanted to. I'm just going to take the second equation, and I'm going to make it negative. So I'm going to multiply everything by a -1, even the thing that's farthest away, even that 8. So then I have 2x plus y is equal to 4, and now I'm going to change the signs of everything. So all of that changed. So now my y's have same coefficients, opposite signs, so I can go ahead and add down my columns. 2x minus 3x is -x. My y's are going to cancel out. That's why I have same coefficient, opposite signs. And 4 minus 8 is going to be a -4. Well, I don't want to know what -x is equal to, so to get rid of that negative, I'm going to divide both sides by a -1. So then I get that x is equal to 4. Okay, so then now that I know that x is equal to 4, I can go ahead and I can, oops, sorry guys, I can go ahead and I can plug that in. So where I see x up here, I'm going to plug in 4. I'm going to take that second equation and I'm going to put 4 in instead. So everything else stays the same except that I plugged in that 4 for x. So then I have 8 plus y is equal to 4. Subtract 8 from both sides, and then I get that y is equal to a -4. So then I want to write out my coordinate point x, y for my final answer. Okay. Next, let's take a look at number 5. So again, for number 5, I have same coefficients, but I don't have opposite signs. So what I need to do is to create that opposite sign. So I can see that I have the same coefficients here, but I don't have an opposite sign. So I'm going to take that second equation and multiply it by a -1. So my top equation is going to stay the exact same. And then my second equation, I'm going to take and distribute that -1 to every single part. So then I have -2x minus 2y is equal to -6. So 2x minus 2x is going to cancel. -3y minus 2y, that's like adding numbers, okay? When you add two negative numbers, it's going to get more negative. So that's going to give me a -5y, and then that's going to be equal to 11 minus 6 is a +5. So now I'm going to divide both sides by a -5, and I get 5 divided by 5, which is -5, which is a -1. Okay, so then we have a -1 here. So where I see y up in one of these equations, let's just choose this first one, I'm going to take the y out and put in -1 instead. Again, I just always pick the first one. You could use the second one if you want to. So I'm keeping that equation the exact same. I'm taking the y out, and I'm putting -1 in instead. So 2x, -3 times -1 is +3 is equal to 11. So now to solve for x, I'm going to subtract 3 from both sides. And then I get that 2x is equal to 8. Divide both sides by 2. And I get that x is equal to 4. So now we know that x is equal to 4 and y is equal to -1. So I can go ahead and I can write that out as a coordinate point x and then y. Okay? Oops, -1. Okay. So let's go ahead and I want to skip number 6. Okay, I'm going to skip number 6 because I want to focus more on 7 and 8. So what I noticed for 7 and 8 is that I have one of the two things I need, but it's not the thing that we're used to. I noticed that my ends have opposite signs, but they don't have same coefficients. So I have 1n and I have 3n. So that's not a plus, that's a 3n. So I want to ask myself, how can I take 1n and make it 3n using multiplication? And so to do that, I'm going to have to multiply by 3. So to take 1 and get it to be 3 using multiplication, I need to multiply by 3. So what I'm going to do is I'm going to take this 3 and I'm going to distribute it into that second equation. So I have 6m plus 3n is equal to 3. So then 3 times m is 3m. 3 times a negative n is a negative 3n. 3 times 8 is 24. And so when I do that, I have the same coefficient with the opposite sign. So I can go ahead and add down the columns. 6m plus 3m is going to give me 9. This should be an m. 9m. And then these guys are going to cancel. 3 plus 24 gives me 27. So now I'm going to divide both sides by 9. And 27 divided by 9 is 3. So now I know that m is equal to 3. So I'm going to go back up here, and again, I'm going to take this first equation. So I'm going to take that first equation. Now wherever I see an m, I'm going to take that m out, and I'm going to put 3 in instead. So I took that m out, and then I have plus 3n is equal to 3. Well, 6 times 3 is 18, minus 3n is equal to 3. So now I need to get that 18 over to the other side. Well, it's a positive 18, so I'm going to subtract 18 from both sides. And then I get a negative 3n is equal to a negative 15. So then I need to divide both sides by a negative 3. When you divide a negative by a negative, it's going to be positive. So 15 divided by 3 is going to be 5. Okay, when you divide a negative by a negative. So then my solution for that one, let's just write it in alphabetical order, would be 3 and 5. All right, so let's take a look at number 8. So for number 8, I notice that my y's have opposite signs. Okay, my y's have opposite signs, so I'm halfway to what I need. So I have 3, and somehow I need to take 3 and make it multiply to 12. So then I ask myself, okay, what do I need to multiply 3 by to get 12? Well, I need to multiply 3 by 4. So I'm going to take this first equation and I'm going to multiply it by 4. So I'm going to multiply each thing in there by 4. So 4 times 2 is 8x. 3 times 4 is 12y. 4 times 2 is 8. And then 4x minus 12y is equal to negative 68. So now we're going to go ahead and we're going to add down the columns. 8x plus 4x is going to give us 12x. 12y minus 12y is going to cancel out. 8 minus 68 is going to give us a negative 60. And then we're going to divide both sides by 12 to solve for x. And that's going to give us x is equal to negative 5, since it's negative 60 divided by 12. So since x is equal to that, next thing I want to do is I want to plug that back in. So I'm going to take this equation right here, and I'm going to rewrite it out. So wherever I see an x, I'm going to put in a negative 5, and then the rest of the equation is going to stay the exact same. So 2 times negative 5 is negative 10, plus 3y is equal to 2. So then I need to add 10 to both sides so I can solve for 3y. And then I get that 3y is equal to 12. So to solve for y, I'm going to divide both sides by 3. And then I get that y is equal to 12 divided by 3, which is 4. So then x is equal to negative 5, y is equal to 4. So solution to the coordinate point is negative 5, 4. And that's your final answer. So go ahead and show me your note sheet once you're done, and I will give you the homework. Thanks for listening.